I'd like to start off by thanking you for taking the time to attend today's presentation. My name is Lance Zurich, and I am the product manager for the fischertechnik Education Division over here at Studica. And of course, today we're going to provide you with an overview of fischertechnik's line of pre-assembled industrial simulation and training models, including some of the latest models, which are incorporating some very cool cutting-edge technology. So let's make sure we're moving. So over the years, I would typically talking about changes in the manufacturing environment and, of course, the growing need for highly skilled workers in the modern workforce. At this point, I think it's been pretty well established just why technology-focused education like this is so necessary. So we're going to pretty much dispense with any preamble and jump right into the discussion of what exactly fischertechnik is. And then I'm going to show you the current models that are available in the simulation family. So fischertechnik simulation models have been designed with the intent of providing a compact, engaging and hands-on method for teaching, demonstrating, and learning about high-end automated systems. Now, this line consists of a series of pre-assembled small-scale models which are
Hey
designed to
Lance, I'm
replicate.
having a trouble with the audio recording.
Okay,
Can you hear me?
I can hear you, yes. And what would you like me to do? Christy? Yep. Christy? Okay, we may be having some problems here. Well, not maybe. We apparently are having problems here. Um, okay. Well, let's just do that. Okay. Uh, I'm not sure what I should be doing, Christy, because I can't. If if I can ask our attendee, if you could just, Sarah, if you could just let us know, are you hearing me? Because apparently Christy is losing my audio, and I want to know if you are hearing me or not. If you could just use one of the. Yes, that's what I'm asking. Yes. Um, yes, if you could just type in the chat window. Okay, the chat is disabled. All right. But you can hear me. Okay. All right. Let's just as long as Sarah can hear me, Christy, if you can't, you've heard it before. Okay. Sorry about that. Let's try to pick up here. So let me get back on my notes and bear with me a second. So bing. Okay. So think. Okay, so you heard about appearance and function, what have you. So before we begin to look at each of the models, what I'm going to do is I'm going to provide you with a little bit of background. So fischertechnik has been creating tools for teaching students of all ages about how technology works for over 60 years now, all based around their unique building system. Now, what makes this system unique is that unlike other popular construction systems where the components are designed to simply stack, the fischertechnik system was created with more of an engineering mindset. Now, the core building block used in the system is designed to enable attachment from all six sides, and because of this, it allows for almost limitless design possibilities. Now, many of the parts are designed to slide together and lock in place using a tongue and groove assembly method, and the hundreds of different parts available will also help builders to address very specific design needs. The fischertechnik system was created back in the 1960s by German inventor Arthur Fischer, who's noted for countless innovations used in both the construction and the automotive industries. Now, at the time of his death in 2016, Mr. Fischer had held more patents in his name than Thomas Alva Edison had amassed during his own lifetime, which is a pretty impressive statistic. Now, just to give you an idea, prior to creating fischertechnik, Mr. Fisher was first noted as the inventor of synchronized flash photography. This was in 1949, and a few years after that, he also gained fame as the creator of the expanding nylon wall plug, which is commonly used in conjunction with a screw or a bolt to help anchor heavy objects to walls. I'm sure we've all used them if you have a house or anything else. Now, among these other things, his company, the Fisher Group, also continues to employ thousands of workers all around the globe who are involved in producing many variations of fastening devices used in building construction. And up until very recently, they also did a lot as far as creating different components used in the automobile industry. And along with this, they also provide consulting services to companies who wish to employ state-of-the-art manufacturing processes. So getting back to it, once again, the focus of fischertechnik building sets, now it's whether those intended for the retail market or for classroom use, the focus has always been on helping to foster an understanding of technology. Now, many of the products that are offered by fischertechnik specifically for the education sector are what we'll sometimes call subject-specific sets, meaning that many of these are sets that either include curriculum or detailed teaching and activity materials. And what they'll do is they'll usually focus on various STEM-related topics, things like mechanics, pneumatics, robotics, renewable energy, and so forth. And in most of these cases, students are going to be asked to build a progression of models using the unique fischertechnik building system, and then they perform various experiments which allow them to explore and understand key aspects of the subject that's being studied. Now, of course, the line of fischertechnik simulation solutions, which are, of course, today's focus, are something much different. The line consists not of kits, but of a series of pre-assembled small-scale models which replicate in appearance and function various automated robotic machines and systems. Now, some of the models included in the fischertechnik simulation line will be things like conveyor belts, punching machines, three-axis pick-and-place robotic arms, color sorting lines, and even high bay warehouse storage systems. Now, besides these individual modules, which will focus on very specific automated processes, fischertechnik also offers several variations of what's essentially an integrated factory simulation model. Now, in these factory simulation models, what you'll most typically see are four individual workstations, most often a vacuum gripper robot, a high bay storage warehouse, a multi-processing station with an oven, and a sorting line with color detection, which are designed to all work together as one self-contained material cycle. Of course, we're going to look at these factory models as well as the individual modules during the course of this presentation. But before we get into that, I'm going to very briefly outline some of the advantages of using fischertechnik solutions. First off, fischertechnik simulation solutions allow educators to offer engaging hands-on tools for teaching, exploring, and understanding various aspects of automation and programming. Now, this can be for understanding how automated systems work, or also for having a tangible physical system to observe and work with in a programming or PLC-focused learning environment. The models, once again, are designed to realistically replicate in both appearance and in function common automated systems such as conveyor belts, sorting machines, robotic arms, and more. Now, because the models are compact and in most cases tabletop sized, they're not only ideal for use in the classroom or for in-office demonstrations, but they're also great for demonstrating software or other technology-based offerings in a trade show environment. The next aspect we'd like to talk about is quality. Each fischertechnik simulation model is a hand-assembled, high-quality, German-made product. Each model is available in 24-volt versions specifically for industrial users, and there are also select models available in 9-volt versions for those not versed in the use of PLCs. Now, as far as the 24 volt versions, they're designed to be used with industry standard PLCs. And it doesn't matter if you use Allen Bradley controllers, if you use Siemens controllers, if you use controllers from companies like Honeywell, Mitsubishi, General Electric, the list could go on. Essentially, these 24 volt models can be controlled with the PLC of your choice. Now, likewise, just as you can use your choice of controller, you can also use your preferred programming language from the programming languages listed on the screen. Now, do note that with these 24 volt versions, for at least most of what I'm going to be talking about in the first section of the presentation, that no PLC is included, the programming is not included, what have you. So, at least in the beginning section of this presentation, when we look at the individual modules, these are going to be something where the end user will need to do the wiring from the model to the PLC connection board. You would, of course, have to have a PLC. You would, of course, have to be fluent enough in one of these programming languages and, of course, have access to the programming language so that you can create the program that's going to be needed. There will be some models where this is not going to be as much of a factor, and of course, we'll mention that as it comes up. But otherwise, at least for the first half of this presentation, know that you're going to have to provide your own PLC wiring and programming. Now, there are also, besides that, there are also 9 volt versions available in select models. And in the case of these 9 volt versions, they will ship pre-wired to Fischer Technic's own proprietary robotics controller, which is the Robotics TXT controller. And in the case of these 9 volt models, each controller is going to be pre-programmed using Fischer Technic's proprietary software, which is RoboPro coding, or in some cases, it'll use C, C++. Now, in the case of the 9 volt versions, the only additional component required most typically is going to be the addition of one or more 120 volt power adapters, depending upon how many TXT controllers are included. But otherwise, you can really think of these 9 volt versions as being pretty essentially ready to use out of the box. Next up, if you're involved in demonstrating or exploring IoT, of course, the Internet of Things, besides the fact that many end users on their own have adapted the models in the Fisher Technic's primary line to use them for IoT purposes, doing, certain changes to the models, Fisher Technic now also offers a special IoT-focused version of the factory simulation I mentioned earlier, which is designed specifically for exploring and understanding cloud-based control and what is sometimes referred to as Factory 4.0. Now, in the case of these factories, the model is designed to be both controlled and monitored from a special web-based dashboard. And of course, we're going to discuss this in more detail in just a few minutes. Finally, Fisher Technic simulation models are cost effective. Now, if you've had the opportunity to look into any of the other hardware-based industrial simulation options that are available in the marketplace, you'll probably notice that while the entry point for many of these products can easily be $30,000 to $40,000 or even much more, Fisher Technic simulation solutions start at just a fraction of that price. And again, they're compact, realistic, and high quality learning and demonstration tools. So, on that note, we're going to begin a look with each of the models that are currently available. And again, we're going to begin with a look at some of the more basic modules, and we're going to work our way up to some of the larger factory models, which again will consist of several individual workstations designed to showcase an entire production cycle. But before we get to the production cycle, we're going to start off with the conveyor belt. And this is essentially a transport belt with a length of 275 millimeters that's used to transport work pieces with a diameter of up to 29 millimeters. Multiple conveyors can easily be connected to increase the length of transport as you might desire. Components on this model will include an excess motor, a push-button limit switch, 2 photo transistors, and 2 LED light barriers. The dimensions are approximately 14 by 10 by 4 inches, and it has a weight of just about 2 pounds. The model is currently available in both a 24 volt version with a multi-pin connector, which is 26 pins in a 2.54 millimeter grid, as you see here. Again, the 24 volt version of the model, as with all but the second half of the 24 volt models we're going to look at later. Again, these models will require you to provide the PLC, the programming, etc. There is also a 9-volt version, which comes connected to a pre-programmed robotics TXT controller, as is shown here. And in this case, you need one power adapter with it. I will mention that for this and all the other models that we're going to look at today, there are specs and data sheets and things of that nature that can all be found on the list in the listings on the Studica website, or if you go to the fischertechnik.biz website, which we maintain in the US for Fischer Technic products. So if you want any of this if you want any more of the details, you can, download sheets and what have you. And of course, you can also contact me directly. I'll give you information on doing that as well. The next thing we're going to be looking at is going to be the indexed line with machining stations. And essentially, this is a model that features a U-shaped conveyor line consisting of a milling and a drilling station, and it has 4 conveyor belt sections. Other components on this model will include 8 excess motors, 4 push-button limit switches, 5 phototransistors, and 5 LED light barriers. It has dimensions of approximately 19 by 18 by 11 inches. It has a weight of about 8 pounds. Again, the 24-volt version has a 26-pin connector with a 2.54 millimeter grid for use with the PLC of your choice. And there is a 9-volt version that comes pre-wired to the pre-programmed robotics TXT controllers, 2 of those, and so you'll need 2 power adapters for that. I will also mention, as you see, since I'm just showing static slides right now, we're going to only have like another 1 or 2 models where it's this format, and then we're going to get into a video section, so don't fear, you will see some motion here. The next up that we're going to look at is a variation on the idea of a pick-and-place robot, which is the 3D or 3-axis robot. Now, the 3-axis robot has gripping forceps, which it uses to help it quickly and precisely position the workpieces that it picks up in 3-dimensional space. The degrees of freedom for this robot are as follows. Axis 1 can turn 180 degrees. Axis 2 can move forward or backwards 90 millimeters, and Axis 3 can raise or lower 150 millimeters. Components on this model include 2 excess motors, 2 encoder motors, and 4 push-button limit switches. Dimensions on this model are approximately 19 by 16 by 9 inches, and it has a weight of just about 6 pounds. Now, as with the other models we've looked at, this is again available in both the 24-volt version with the 26-pin connector and a 2.54 millimeter grid, designed again for the use with the PLC and the programming of your choice. Or, nope, the 9-volt version is no longer available. That's why the slide is gone, so just let's skip that one. Now, the next up is going to be the vacuum gripper robot, which you see here. And starting here, we get to show you what the model looks like in action. So what you're about to see here is the vacuum gripper, which is a 3-axis robotic model with a vacuum gripping device attached to it. The model is designed to precisely pick up and position workpieces in 3-dimensional space. Now, this model includes 3 encoder motors, 3 push-button limit switches. It has a vacuum suction device, a compressor, and a solenoid valve. The dimensions for the model are approximately 9 by 19 by 15 inches. It has a weight of just about 7 pounds. And the 24-volt version of this model, as well as all of the 24-volt models we're going to be looking at moving forward, each have a relay board for motor polarity reversal and both a multi-pin connector. And in this case, they start off and moving forward again, 34 pins with a grid of 2.54 millimeters, as well as additional PCB terminals with pushing connections for all inputs and outputs. Again, the 24-volt version of this model, as well as with all the 24-volt versions, will require you to provide the PLC and the programming. And as I'm checking my list here to see if we still have access to a 9-volt version, it looks like that is unfortunately no longer the case. So no 9-volt on this one. We're going to let this play out. And I think there we go. The next thing we're going to look at is the high bay warehouse. Now, the model you're going to see here is a high bay warehouse and it features a transfer station with a conveyor belt, along with a shelf stacking mechanism for storing and retrieving workpiece carrier trays and 9 individual storage spots for the trays to be placed. Components on this model include the two encoder motors, two mini motors, four push button limit switches, two photo transistors, two LED light barriers, and a selection of different colored workpieces along with carrier trays for each. Now, part of the reason why I always go over the components when I'm doing this presentation is because these are the things that people who are involved, of course, with programming classes like to know about because these are the things the students are going to have to deal with. Now, another thing is, in particular with this model, uh, teachers that I've talked to who are involved in the programming end love this because of so many details they have to be paid attention to. Again, the precision with how the piece needs to be pulled off the conveyor, moved by the arm, put into the different slots, retrieved, and what have you. This gives a lot of programming stuff for the students to work on. So that's something why it's kind of a favorite for them. Anyway, getting back to the brass tacks, the dimensions of the model are approximately 19 by 28.5 by 15 inches. It has a weight of 18 pounds. Again, 24-volt version has a relay board for motor polarity reversal, multi-pin connector, 34 pins with a grid of 2.54 millimeter, as well as additional PCB terminals with pushing connections for all inputs and outputs. And you do need to provide your own PLC and programming. There is a 9-volt version available, comes pre-wired to a pre-programmed robotics T controller, and you need one power adapter for that. That was a lot of talking. Next up, we're looking at the multi-processing station with an oven. So what you're going to see here is a furnace simulation with a pneumatic sliding door. Uh, Essentially, it's a downstream processing station with a pneumatic transfer unit that includes a vacuum gripper. It has a cutter with a rotary table, a simulated cutter, and a conveyor belt. Components you'll find on this model include four mini motors, six push-button limit switches, two photo transistors, two LED light barriers, four solenoid valves, and a compressor. The dimensions for the model are approximately 20 by 14 by 12 inches. It has a weight of about 11 pounds. Again, it's available in both a 24-volt version for use with the PLC of your choice, with once again, relay board for motor polarity reversal, and both multi-pin connector, 34 pins with a grid of 2.54 millimeters, as well as additional PCB terminals with push-in connections for all inputs and outputs. And the 9-volt version, in this case, is connected to two robotics T controllers. So, of course, two power adapters would be required for all operations. We'll let that go through, play out a little bit here. More processing going on. And the part is delivered. Cool. Next up, we're going to look at the sorting line with color detection. The simulation you're going to see here features a system for detecting work pieces of different colors and sorting them via conveyor belt into 3 different storage bins. Components that you'll find in this model include 2 mini motors, 5 photo transistors, 5 LED light barriers, 3 solenoid valves, a compressor, and an optical color sensor. The dimensions for the model are approximately 20 by 14 by 12 inches. It has a weight of about 10 pounds. As with the models I've discussed before, the 24-volt version has a relay board for motor polarity reversal and both a multi-pin connector, 34 pins with a grid of 2.54 millimeters, as well as additional PCB terminals with pushing connections for all inputs and outputs. Again, the end user must provide the PLC on the programming and the wiring, etc. The 9-volt version comes pre-wired to a pre-programmed robotics T controller, and one 120-volt power adapter is required for that. So we'll let this play through. And after this, we're going to start looking at the factory variations. So The next model is the factory simulation, which essentially combines the last four models that we reviewed. Again, the vacuum gripper robot, the automated high bay warehouse, the multi-processing station with the oven, and the sorting line with color detection. It combines those four models into one self-contained material cycle. And what you're going to see in this video is a cycle that works like this. Work pieces are retrieved from the automated high bay warehouse where they've basically been stored, and they're retrieved using the vacuum gripper robot. The vacuum gripper robot then moves the piece to the multi-processing station with the oven. After the workpiece has been processed by that machine, it's then moved into the sorting line where it's sorted by color in the sorting line with color detection. And after that's been done, the gripper will again take the workpiece and move it back to the automated high bay warehouse once again for storage. So it basically can go through this whole a simple work cycle, as I mentioned. Now, as we've already discussed the components of each model previously, I'm not going to belabor it by restating them here, but what I want to mention are the dimensions of this model as a whole. As you see with people sitting around it, it combines the four individual models into this one work cycle, and because of this, it has a much larger footprint. In this case, it's a footprint of 39 by 31 by 16 inches. It has a weight of between 43 and 46 pounds, depending upon whether it's the version for PLC or for not. Now, due to these dimensions and the weight and the fact that it does, again, come fully assembled, this model, if you're ordering it, does need to be shipped flat as freight on a pallet. It's not something we can send UPS or FedEx. It has to be shipped by truck. And I also want to point out that as these factory simulation models can be in high demand, you do want to keep that in mind as well. Like some of the we try to keep some of each in stock, but if you're going to need multiples of these, just keep that in mind. There might be a little bit of a lead time, 2 to 3 weeks. A few other things to note. This one is only available currently in a 24-volt version, uh, just for reference. So it's also going to include uh, a TXT controller. Excuse me. Yeah, let me see here. Nope, the 24-volt version has one TXT controller that you will need a power adapter for. Sorry about the confusion there. Anyway, before we move on to the next group of models, I do want to mention that there is a storage option that's available for those users of the factory simulation that we just discussed, or the models that we're going to be looking at ahead to help protect it and store it when not in use, or obviously protect it when it's being moved around. Now, the travel case that you're looking at consists of an aluminum case maker profile with plastic plates and steel ball corners, as well as four steel tilt handles and angle protection corners. Now, the upper section of the case is partially lined with soft foam blocks in different heights, which will help to cushion the model. And it also has three internal zipper pockets for storing the cables, the work pieces, the other accessories that are going to be needed. Now, the lower portion of the case, as you see, is lined with harder foam, and it's designed so that once the top of the travel case is removed, the factory model, can remain resting in the bottom section of the case and still be fully functional. The case itself has external dimensions of approximately 41 by 33 by 17 inches. It has a weight empty of 53 pounds. So keeping in mind that if you put either of the two, the factories that we looked at, if you put the factory in there, you're essentially looking at about 100 pounds in weight. Again, even when you're using the travel case, this is still something you always want to store or transport flat and ship as flat as freight on a pallet if you ever have to do any shipping of it. Now, the next group of models that we're going to be looking at focus specifically on the area of IoT, and these we will call the Training Factory Industry 4.0 models. Now, this group of models was designed to help address how the recent changes in industrial production, which were driven by digitization, have helped to create a need for stronger networking and more relevant information on all production levels. Now, with this Industry 4.0 update of the factory simulation we looked at a few minutes ago, with this, such digitization activities can be simulated, they can be learned, and they can be applied on a smaller scale before, of course, they're implemented on a larger scale. Now, as the video that we're going to look at here has a really nicely narrated overview of just how the factory works, I'm going to back up for a minute and allow you to watch and listen to the narrator. So here you go.
fischertechnik Learning Factory 4.0 illustrates processes for a digitized smart factory, from delivering raw material to the finished product. Industry 4.0 applications can be tested and demonstrated using the simulation model that has already been set up. Digitization activities are simulated on a small scale and learned before they are used on a large scale. The training and simulation model demonstrates the process from the delivery, collection, and storing of the materials through the ordering and the manufacturing processes to delivering the finished product. The training factory industry is controlled by a PLC controller, a Raspberry Pi as IoT gateway, and a TXT controller. The PLC program controls the individual modules of the factory. The program is written in structured text. The PLC communicates via the standard OPC UA protocol with the Raspberry Pi, which acts as an IoT gateway to connect the factory to any cloud. The program on the Raspberry Pi is implemented in Node-RED. In Node-RED, there is an additional local dashboard available, which can be adapted to your own needs. The Raspberry Pi also communicates with the TXT controller via the standard MQTT protocol, which in turn enables access to the fischertechnik cloud. The program on the TXT controller is executed in CC++. The sensor image data are used and monitored in the fischertechnik cloud. The integrated WLAN router transmits factory process data to the cloud in real time. The data is presented on a web-based dashboard. 3 views are available: the customer view, supplier view, and production view. The views and data can be accessed using internet-enabled devices and can also be used remotely. The USB camera is controlled from the cloud and can view the entire factory. A sensor station measures air pressure, air quality, temperature, humidity, and brightness. The default process cycle begins with storing and identifying the material. Using RFID NFC technology ensures that the material can be digitally traced. The integrated NFC tag stores production data that can be read out via the RFID NFC module. The cloud displays the part's color and the ID number. The vacuum gripper places suction on the material and transports it safely to the high bay warehouse. The production view on the dashboard shows where the product is in the manufacturing process. The first-in, first-out principle applies to outsourcing. The goods that were stored first are also the first to be removed. Ordering material is triggered online on the dashboard. The desired product and the corresponding color are selected in the customer view and then placed in the shopping cart. Customer-specific production takes place in lot size 1. The production process is simulated in 2 steps. The suction gripper passes the material on from one step to the next. The material is transferred to the sorting system once production is complete. The sorting system receives the allocation command as soon as the color sorter detects the proper color. material is sorted using pneumatic cylinders. The production data is written on the material at the end of the production process. The finished product will be provided for collection. Instructional material and the source code for the stored programs are available online. The fischertechnik Learning Factory 4.0 is ideally suited for education and training in vocational schools and companies, for research and teaching in colleges and universities, for development projects in IT departments, for production planners, and for demonstrating in-house software solutions at trade shows and other corporate events. The customized storage and transport case is a worthwhile add-on.
Okay, so just to jump in and summarize a few of the points quickly, here are some of the topic areas which can be addressed using the fischertechnik Training Factory Industry 4.0. Of course, training and simulation on a realistic production model, in-depth learning through haptic comprehension, optical and sensory applications, digital traceability with NFC/RFID technology, customized production in lot size 1, integrated cloud connection and control via smart devices. You can work on the using and operating of dashboards, using web-based remote maintenance, the linking of production and materials planning data, and the connection of upstream and downstream logistics processes. Now, as you just saw, the model incorporates many features not found in the models that we looked at earlier, perhaps most notably being the use of the cloud-based dashboard for monitoring and controlling the model. Some other examples would be things like the camera that's used for visually monitoring the factory functions from the cloud-based dashboard, as well as the environmental sensor, which collects data on variables such as temperature, air quality, humidity, and air pressure on the factory floor. The use of NFC chips in each of the work pieces enables the position of each of these pieces in the work cycle to be mapped. And the use of MQTT, or message queuing telemetry transport, allows the network TXT controllers communicate with each other in the 9-volt version, or of course it's also used in the 24-volt version to help the PLC talk to the internet. Now, in regards to the 24-volt version specifically because of that, I should note that it's a bit of a hybrid. Again, while it requires a PLC for operating and controlling the main model, it also does incorporate the one fischertechnik TXT controller. And in this case, again, as I was saying, the TXT controller serves as the MQTT broker and interface to the fischertechnik cloud. Communication between the PLC and the TXT controller is carried out using an IoT gateway via OPC UA. Now, OPC UA, which is also known as OPC Unified Architecture, is, of course, a standard for exchanging data across different platforms like this. Now, in addition to the TXT controller that's used here, there's also an IoT gateway using Raspberry Pi with Node-RED, and this allows the option for not only presenting and using data on a dashboard in the fischertechnik cloud that's maintained by fischertechnik, but also to be able to display data and calibrate the stations in your own of the factory in your own Node-RED dashboard. So you have that option. Now, the model also incorporates newly developed 24-volt adapter boards to interface to the PLC. And these, of course, will ship as part of the assembled training factory and are connected to the PLC via terminals. Now, among other things, the latest generation of adapter boards allow for the speed of the encoder motors to be controlled via PWM, or pulse width modulation. And they also have push-pull output stages for photo transistors and for buttons. Now, unlike the previous 24-volt versions that we've discussed, the new 24-volt Training Factory Industry 4.0 includes access to a sample program. Now, in this case, the program was created in structured text ST format, and it was created based around a Siemens S7 1500 PLC. And this is available for download on GitHub. So you could even download that now. You can go to GitHub. If you go into the manual, you'll see a link and you can download it and check out the programming for it. Now, of course, the model, the training factory, can also be controlled with other PLC models besides the Siemens S7. And so if you were going to use a different PLC brand or make or what have you, you just have to make some adjustments to the sample program. And because of this, the source code for the program is also available from GitHub, so you can download all that there. Now, all of this information, like when I'm talking about the links on GitHub, this is included in a 152-page PDF manual, which you can download either directly from the Fisher Technic website, from our own website. If you're not able to access it, you can email me directly, and I'll be happy to send that to you. And this is something you can feel free to review before you actually purchase one of these factories. So if you'd like to see that, please let me know. I also need to mention that as of last year, there are two additional variations of the 24-volt model that we just looked at, and we're going to discuss those in just a few minutes as well. Now, in the case of the 9-volt variation of the Training Factory Industry 4.0, it's facilitated through the use of 6 robotics TXT controllers. And again, with the TXT controllers, all the programming is preloaded so that once the connections to the internet and the cloud-based dashboard are made, all of which are clearly outlined in the downloadable documentation manual that comes for this specific set. Once you've done that, once you've made your internet connections and powered up and what have you, you should be able to get started relatively quickly. The 9-volt version will require 3 additional power adapters because the TXT controllers are daisy chained, so you don't need 1 each, you just need 3. Now, it should go without stating as well. I always have to mention this, whether we're talking about the 9-volt or the 24-volt version, because these are IoT-focused models. It also does require that the end user, of course, has the ability to access the internet, as well as a tablet or some other device for accessing the cloud-based dashboard. So just wanted to make sure that's noted as well. Just to get to the dimensions for these models are approximately 39 by 31 by 16 inches. They have a weight of between 51 and 53 pounds, depending on whether it's the PLC or non-PLC version. We do recommend the optional travel case to help protect your model during travel or storage. And that's the Training Factory Industry 4.0 model, which again is available in a 9-volt and a 24-volt variation. Now, we do have some other stuff to talk about. The next one up is the quality control with AI. This model incorporates cutting-edge technology, of course, AI, that's quickly becoming a part of our daily lives. Now, the control with AI system model from Fischer Technic is ideal for visualizing this very complex subject area in a hands-on manner because it creates a sustainable learning experience by linking theory and practice. What you'll see is processes can be sped up, fault rates and costs can be minimized, and fault evaluation can be standardized. Now, the Fischer Technic sorting line here comes with workpieces in 3 different colors, which of course you've seen before, but in this case, the workpieces are marked with 3 different processing characteristics, as well as with various fault patterns. So what happens is the workpiece is put on the conveyor belt. First off, gets scanned by the camera that you see there, and it's classified with the aid of the trained AI. Now, depending upon the color, the feature, or the fault pattern that's shown, the workpieces are then sorted by the artificial intelligence based on their quality features. The AI used is realized with machine learning and TensorFlow, where an artificial neuronal network was trained with image data. Now, the learned AI is executed on the Fischer Technic TXT 4.0 controller. Now, the model sequence control is implemented in the RoboPro coding programming environment and also in Python. Now, if you want to go a step further, you do have the option of generating your own AI applications, and in this case, the training is done in Python, for which a sample program is provided for explanation. And that is essentially the quality control with AI model. Again, it's ideal for training, simulation, and demonstration purposes, and for the visualization of AI systems, machine learning, and neural networks. It is available only in a 9-volt version, and it does require 1 power adapter with it. So as I kind of jumped ahead over here, The next model we're going to look at is the most recently released of the bigger fischertechnik models, and that's the Agile Production Simulation. It's the latest variation on the factory, this time not only incorporating IoT and state-of-the-art manufacturing processes, but also, again, the artificial intelligence element. And it also includes a digital learning platform, which is a big plus. Now, this factory of the future is the subject of numerous research projects in science and industry. Forward-thinking companies, of course, as we know, rely on automation, modularity, artificial intelligence, and the agility to remain competitive. So, in order to promote these topics in industry and research, students and apprentices, employees, they all require corresponding know-how and awareness to know how to deal with these complex issues. And this is where the learning concept behind the agile production simulation comes in. From the goods receipt to modular production to quality assurance. Now, the accompanying learning materials that come along with this model will help to translate the hands-on simulated processes into future skills for both the students and the teachers. And the digital twin of the model will significantly intensify the learning experience. Now, as we don't yet have a narrated video of this brand new model, I'm going to provide you with a quick overview, beginning with the module where incoming and outgoing goods are placed. And after we look at these individual modules, I do have some raw video that I'm going to share with you as well. So you will get to see the factory in motion. But first off, we're going to kind of look at how you would see the modules as they normally are approached. So the first station that you have is the station where the material flow essentially will begin and end. And this is where, as you see, the raw material, in this case, the little work pieces, which you see on the vacuum gripper has it on there right now, that essentially this is where the raw materials enter the process. So the workpiece gets positioned on the color sensor for quality control using the 6-axis robot. And that's another big thing. This is a 6-axis robot that you're going to see here with a vacuum gripper, not a 3-axis robot like we had earlier. So the 6-axis robot places the workpiece on the color sensor, and then it's encoded on the NFC reader. So the robot, after it's been encoded, after the workpiece has been coded, it's going to take the workpiece and place it on the automated guided vehicle, which we're going to see in a minute, the automated guided vehicle, or AGV for short, which will help to transport the workpiece around the factory floor to the stations that it needs to go to. Now, the module where the workpiece enters also contains the central control unit, which in this case is a Raspberry Pi, and it also houses the environmental sensor, which again measures the different environmental conditions in the work factory. Now, there's also an integrated movable camera that's located here, which can be swiveled in 2 axes and provides an insight into the entire factory floor via the fischertechnik cloud-based dashboard, which we, of course, saw an example of in the previous video. Now, again, at the end of the work cycle, after it's gone through the various stations, this is also where the workpiece is delivered back to by the AGV. So again, it begins and ends its journey here. Typically, after this, the next place for the workpiece to go to is usually the high bay warehouse. Although, because this is an agile production simulation, you could, of course, the order of what station that it needs to go to. But let's assume for right now that it's going to the high bay warehouse. This one, again, like the high bay warehouse stations that in the APS model have their own vacuum gripper. So what's going to happen here is the vacuum gripper will take the workpiece, pick it up from the AGV at the docking station. There's a little docking station here, and it will hand the workpiece over to the stacker crane where it is then stored. Well, actually, before it's stored, it's placed in a workpiece carrier, and then it's stored. Retrieval for workpieces is always done using the first in, first out principle. Now, the next station that you're going to encounter is a drilling station. This again has a docking station, as you see right now, the APS, which is the vehicle with the wheel, or the AGV, excuse me, the automated guided vehicle, docks at this workstation, as you see right here, right next to the little conveyor, so that it basically takes again, there's a vacuum gripper here that will take the workpiece, pull it off of the AGV, and put it onto the conveyor belt where it is transported under a drilling head. And essentially what will happen is the simulated drilling process will occur, and then the workpiece is transported back to the gripper on the conveyor belt, where again the gripper picks up the workpiece, places it back on the AGV, and off to the next station. Then you could typically have the milling station, which again has a docking station for the AGV, a vacuum gripper that places the workpiece onto a conveyor belt from where it is transported under the milling machine, and then the milling of two pockets are simulated on the workpiece. Now, after that process, again, the workpiece placed back on the conveyor belt, transported back to the vacuum gripper. The gripper then moves it back onto the automated guided vehicle, where it goes off to the next station, which is the quality assurance with AI. So here it gets again, the vacuum gripper places the workpiece onto a conveyor belt. The workpiece gets transported underneath the camera and it's scanned there again, much like we saw in the previous slides that I showed. Now, again, the work pieces will come in three different colors, red, white, and blue, with three machining features, either drilling, milling, or drilling and milling features. And it also has various fault patterns. And again, all this gets classified using the trained AI. Now, depending upon the color, the feature, and the fault pattern, in this case, it's the work pieces are not sorted into separate bins as they were before, but it either gets placed back onto the AGV as being as an acceptable good to go workpiece, or it's put into a reject container, meaning that it's not okay or defective. And here is the AGV, since I talk about it, but we hadn't seen a really clear photo of it up until now. This is the AGV, and essentially the AGV transports the workpieces again from one of these modular stations to another. It's a track-bound vehicle that follows the printed black tracks that you see on the floor of the factory, and it uses ultrasonic sensors to help it detect obstacles that might be in its place. The vehicle itself has omni wheels, which allow it to move in all directions. Two buttons and a photo transistor on the vehicle help the vehicle to dock to the individual factory modules at their docking stations. The AGV receives its driving commands from the central control unit, which is an industry standard VDE 5050, and it uses a fischertechnik rechargeable battery pack as its power supply. Now, speaking of the battery pack, when the battery on the AGV runs low, the AGV will navigate towards a charging dock where it is automatically charged with a charger with charge monitoring. There are contacts on the bottom of the charging station that can connect with the AGV, the underneath of the AGV, and its charging electronics. And there you go, you get it charged up. Moving right along, just to quickly review some of the technical specifications, it's a 24 volt power supply, 11 amps. The central control is again Raspberry Pi 4B. The individual modules each are controlled with the help of their own Siemens S7 1200 PLCs. So in total, this model contains 5 Siemens S7 1200 PLCs. Now, besides that, the model also includes 3 fischertechnik TXT 4.0 controllers, which are used to control the sensors and the camera, as well as to help to facilitate cloud access in the WEWA module for quality assurance with AI, as well as for the automated guided vehicle. It does have a WLAN router for the WLAN network. Some of the software used on the APS model will include SPS programs and structured text for the of course, TypeScript for central control of the Raspberry Pi, Node-RED for communication between the SPS and the fischertechnik TXT 4.0 controller, Python for programs on the TXT 4.0 controllers, and TensorFlow, again, for supervised learning and the quality assurance with AI module. Now, again, there is a digital learning platform with a digital twin of the APS model, and this is so that learning can be done with both the actual model as well as a virtual model. Now, as there's a lot more detail to cover on the Agile production simulation than we can go over here in a few minutes, if you would like to know more, I would strongly encourage you to sign up for our new webinar, which focuses specifically on the Agile production simulation model, and it discusses why the model is so useful. But this will just, for now, this kind of gives you a quick overview of the APS. Oh, I thought I had video in here. I'm sorry, I do not. Okay. So anyway, you might be wondering how much these models cost and what might be involved. So we're going to take a quick look at each of the options I've discussed along with the pricing for each. So first up, the conveyor belt. The 24-volt version is $459.95. Again, you need to provide your own PLC programming and wiring from the model. The 9-volt version, which comes with the TXT controller, which has been pre-programmed, is only $518.95. The index line with 2 machining stations. This is a limited production model. So if it's something you're interested in, you might want to jump on these sooner than later. The 24-volt version is $1,379.95. The 9-volt version, which comes with, again, pre-wired to the TXT controllers, is $1,394.95. The 3D 3-axis robot, only available in the 24-volt version. It has a cost of $1,249.95. The vacuum gripper robot, also currently available only in a 24-volt version, $1,479.95. The automated high bay warehouse in the 24-volt version, $1,799.95. The 9-volt version, $1,318.95. Again, all these 24-volt versions we've looked at so far, you need to provide your own PLC programming, etc. The multi-processing station with oven, the 24-volt version, $1,479.95. The 9-volt version with the TXT controller is exactly the same price, $1,479.95. The sorting line with color detection, the 24-volt version, $1,387.95. The 9-volt version, $1,128.95. That's interesting. The factory simulation. This is the basic non-IoT version of the factory. So again, if you're not interested in cloud control and what have you, you just want to work with an automated system. You want to have something that just on the desktop that you can work with that way. None of that needed. This would be what would be of interest to you. The 24-volt version only. The cost for this currently is $6,479.95. You do need your own PLC and programming and wiring and power supply for that. Now, when we get into the training factory industry 4.0, this is where you're going to start having a few more options. Controllers is also the same price, $11,099.95. The difference here, though, is again, the 24-volt version does come with a sample program. In this case, it is in structured text format, again, designed for a Siemens S7 1500 PLC. And aside from that, there are 2 other versions that are available. There is a version of the 24-volt that does include the PLC connector board and the cabling and that power supply, which I talked about before. The cost for this is $15,734.95. You still need to provide your own PLC, but it still does come with the programming. And then there is also a version that does include the PLC. It includes the Siemens S7 1500 PLC. So this is about as ready out of the box as you're going to get with the 24-volt versions. So again, it has the connection board, it has the wiring, it has the PLC, it has the program, it has the power supply. This is, so you can go get started right away. The cost for this, if you are an educational customer, is $24,049.95. If you're a commercial customer, it is slightly more, $24,439.95. So again, Training Factory Industry 4.0, when we're talking about these These other versions, again, the PLC connector board, it's $15,734.95. You still need your own PLC, or if you want the PLC S7 1500 connected and you want everything ready to go, again, $24,049.95 for educational customers, $24,439.95 for commercial customers. Other items, I keep talking about these power adapters. They are $12.99 each. Again, if there's any questions about whether you need them or how many you might need, just of course at the time of ordering, just ask about those. Travel and storage case. This is recommended specifically for either the factory simulation, that's the non-IoT factory, or for any of the training factory industry 4.0 variations. The travel case is $1,849.95 each. The quality control with AI model, it is only available in the 9-volt version. That's going to have, of course, your TXT, which is pre-programmed using RoboPro coding in Python. It's essentially just going to need the one power adapter, and your cost for that is $2,589.95. The Agile production simulation, which we looked at before, of course, this is 24-volt only. It again includes 5 Siemens S7 1200 PLCs and 3 fischertechnik TXT 4.0 controllers. It does include the programming. It includes the power supply. It has all that stuff. It includes the digital twin. The cost for this package is $35,174.95. And even though that's a lot, that's pretty much your starting point for a lot of the other simulation models from other manufacturers. So this is where we end up. That's where they start off. So that's kind of what you're looking at as far as why we're more cost effective. Next up, there is a storage case specifically for the Agile production simulation. As you see here, it's $4,799.95. It is a 2-tier case. Again, you see there's the harder foam over here, but this one, it stores different than when we looked at the other factory variation where the factory can rest in the bottom of the case when you take the top off. With this one, because the APS model is a little bit different, what you have to do is in the 2 tiers of the case, you'll have to store different modules in different tiers. So this one does kind of come apart. Again, if you flip back to this one, you can see that there are little prongs on the side of the factory floor. So this is going to be kind of like giant puzzle pieces that you'll have to put together on the whatever table or desktop this is on. So again, comes off in modules. There are, again, zipper pockets and various bands to help you store the components, the wiring, the cabling, the manual, and any other things. Keep everything safe and nice and clean. Again, your cost for that is $4,799.95. But wait, there's more. There's just a couple other things to mention real quick before you go anywhere. Again, as you saw, there is a 6-axis robot that is part of the Agile production simulation. It is also now available as a standalone model in the 9-volt version only. Cost for this is $1,849.95. So if you just need a 6-axis robotic arm, again, comes pre-programmed with the robotics TXT controller. You will need a power supply with that. There are a couple new 24-volt models that just came out. There's the production line, which is a cool little model over here. It has a 24-volt version. It is $2,034.95. This does, besides, and again, you provide your programming and what have you, but the nice thing about this one is it includes a PLC programming course. So you provide your own PLC, you provide your programming, but you have a PLC programming course that comes with this one, and also with another new model, the bending machine. Again, PLC programming course. The cost for this is $999.95. And then we have 2 add-ons. These are specifically for the APS, the Agile Production Simulation. You can add a second AGV, automated guided vehicle, to the factory floor. This makes things interesting for your programming students and what have you, but it's a very cool concept. The cost for an additional AGV is $2,589.95. There is also an add-on module and annealing furnace that can be added. So this can be another station for the APS. It does, of course, include its own Siemens S7 1200 PLC already pre-wired in there, as you see right in the photo. The cost for this module is $4,439.95. And I do want to mention that whether we're talking about this module or the original AGV, these are only intended for use with the APS, the Agile Production Simulation. These would not be standalone models. So this one or this one, you're only purchasing this if you already have the APS model. So at that point, if you do have any questions, right now what we're using the chat window. So whether it's the question and answer window or the participant window or what have you. So either way, if you did, I don't see anything coming up. So if you'd like to take the next step, if you'd like to request our 2025 Higher Education and Industry Guide and the current price list, if you'd like to ask any questions directly, if